This is the talk on ETL with Meltano and Singer in the LLM era, and I'm Pat Nadolny. So I'll first just give you the about me. I'm actually a senior software engineer now at Arch. Just very recent changes, but the company formerly known as Meltano. I have about 9 years of experience in doing data things, data engineering, analyst, things like that. I've been a longtime contributor to Meltano and the Singer ecosystem in general. Okay, so what I'll talk about today is kind of like the first two pieces are the open source aspects of all of this, the Singer spec is, the Meltano project and the open source ecosystem around it. And then I'll get into the third topic, which is data engineering with LLMs, and that I'll show sort of a demo, and I'll go through some of the findings that I shared in a blog post back in August. But we'll get into that later. So to jump right in, the first piece, what is the Singer spec? If you haven't heard of it, the Singer spec was created by Stitch in a company called Stitch in 2016. It's basically a specification for data interchange for ELT pipelines. So traditionally being like replicating data out of a database for reporting purposes, writing to mostly like Snowflake or your data warehouse type things. The idea being that we're going to be sending JSON over Unix pipe via standard out, and it bakes in a lot of features that are going to be useful for basically everybody who wants to use the connectors in this way. Things like incremental state and schema messages, so you can validate that the data is what is in the form that you expect. In this world, there's things called taps or extractors. The reader side, that's a connector that reads from a source. And then on the other end, it connects to a target, which is also called a loader, that does the writing to your data warehouse or wherever else. And actually more recently, there's been more reverse ETL use cases for things like that. So the catalog for targets is growing. And these are all standalone GitHub repos and Python packages mostly. So the benefits of Singer are that it's well-defined. It has a lot of the robust features that I just mentioned baked in. The connectors are theoretically interchangeable, so every tap should work with every target. In practice, it's a little different, but I'll get into that later. It's flexible. We've been adding new features to it over time. You can fork projects and customize them as needed. Everything, or most projects are Python Git repos. That's not a requirement, but it's actually a benefit because that's the language of choice for most data teams. And there's a large ecosystem, so tons of implementations to look at when you're trying to make your new connector. Some of the challenges with Singer are that it's sometimes challenging to orchestrate. There's some moving pieces that are difficult to sort of run on your own. In the past, there was inconsistent implementation. And again, I'll get into that and how the Meltano ecosystem comes to this. They were hard to discover because each of these is its own GitHub project. So people were having to search Google or GitHub search or whatever else to try to find the tap they need. And the documentation along with that came in README. So again, it's hard to like find those when you're looking for them. And yeah, and the last piece is contributing. Of course, these are all open source. So sometimes maintainers come and go. So having to solve for those challenges. So what is Meltano? I'll start first with the story of Meltano, which is Meltano was built in 2018 by GitLab's data team in-house, with the insight being that they're looking for a tool that had software engineering features for their data team, but a lot of the data tooling hadn't kept up. So they're looking for things like Git-backed projects and everything is code for code reviews, and they wanted testing and isolated environments. And these are just things that didn't exist in the data tools that were around at the time. 2020 came around. The value of Meltano was sort of ultimately found to be orchestrating Singer ELT connectors here, like I'll mention. And so started to focus in on that. And so the Meltano community embraced Singer, started to bring a suite of products around Meltano itself to solve those challenges I mentioned. And eventually 2021 spun out of GitLab as a standalone company known as Meltano. So The first piece of this under the Meltano umbrella of products is Meltano Core, which is solving the orchestration piece of the Singer ecosystem. So it's enabling you to add these connectors to your project. It's everything as code in YAML, and you can check it into your Git repository, has a CLI, has support for environments for testing, things like that. So that's the first piece, is orchestrating these Singer connectors. The second product is Meltano Singer SDK, which is an SDK. It solves the Singer inconsistent implementation problem, where basically it was up to the users of these, or the builders of these taps, to comply with Singer spec, and that causes sometimes inconsistent implementation. So the SDK handles all that for you. You just basically need to write your logic for connecting to the source that you want to connect to. And has all these nice features for common things like REST APIs and SQL authentication, rate limiting. And I just checked recently, there's 900 Git repos that use this as a dependency. So there's tons and tons of implementations, and people are getting lots of value out of it. The next piece is the Meltano Hub, which solves the discoverability problem with these Singer connectors. It is basically just like a searchable index. You could go on, you get like a documentation page with all the settings that are needed for these connectors. And of course, since it's open source, there's many forks for each thing. So like GitHub might have 5 implementations that are different in certain ways. So you can kind of like pick and choose which ones you're interested in using. And yeah, and the hub also serves an API that Meltano Core uses in order to install these connectors into your project. And then finally, the last piece, one of the challenges of Singer was the contribution and maintenance. So we built Meltano Labs, which is basically just a GitHub organization that allows open source, when a connector has the maintainer or contributor who like sort of they're done with their phase of maintenance, they can sort of we can fork it into the Meltano Labs and bring on contributors who want to be like for a short amount of time be a contributor of this project or whatever else. So it just gives us more flexibility to get features into projects that have maybe lost some steam in the ecosystem. So Meltano and Singer together, these pieces, we have orchestrate that's solved by Meltano Core, implementation of these connectors solved by the Meltano Singer SDK, discovering with Meltano Hub, and contributing and maintaining with Meltano Lab. So kind of all of these pieces are being solved by the combination of Meltano and Singer together. So what is Arch, which is the company formerly known as Meltano, and is the company that I work for? A quick pitch, because we are the primary maintainers of sort of this umbrella of open source tools and have been investing heavily in this over the years. Previously, we were the company Meltano, named after the project itself, focusing on hosting infrastructure for these projects. We found that the community was coming to us asking for more of like an abstraction on top of this, so that they could build more multi-tenant use cases. They don't want to handle the things like OAuth and some of the more complicated things of managing multi-tenant use cases. We still use Meltano heavily under the hood, and we're building some AI features, which I'll talk more about in this talk. So yeah, moving on from there, the sort of main piece of this is LLM apps are mostly data pipelines. Again, like this content is based on a blog post I wrote back in August, and I'll sort of go through a lot of what I found there and summarize, do a little demo. So it starts with the initial excitement of AI, where things like ChatGPT came out, all these open source models started to pop up. There was a lot of investment around tooling in this space. So everybody was very excited. We were very excited as users. And everyone's starting to dig in to see like what these tools are actually doing. So at a certain point, we started to take a step back, and people started to reflect on what patterns started to emerge in this space. And one that sort of caught our eye from the Meltano and sort of data engineering perspective was this A16Z emerging LLM app stack, with the quote here that says, sort of narrowing in on what looks like the data engineering piece that says, this piece of the stack is relatively underdeveloped though, and there's an opportunity for data replication solutions purpose-built for LLM apps, which was interesting to us coming from like an EL space. And I linked some of these like Hacker News comments that were getting a lot of attention. And they're just basically referencing, is this just ETL? Why are we building new ETL when we already have tools that exist for these things? So piqued our interest. We said, maybe let's spend some time digging into this and figure out, is this something that Meltano can help with? And that's basically what I did. I went and dug in, and I shared my findings in the blog post, and I'll share more details here. So the first thing, as I start to dive into this rabbit hole, is the use case, or the difficulty with the pre-trained models that exist, something like OpenAI's GPT models. It doesn't have your domain-specific knowledge, and sometimes you get responses like, I think we've all run into this, where it says, "Sorry, I was trained on data back in 2021." So like, people were constantly running into this difficulty, and they were trying to figure out how it can understand your specific domain. So the first sort of implementation of this, or like obvious way to solve this problem, is to fine tune the pre-trained LLM, which this diagram on the right sort of shows, where you take the pre-trained LLM, you feed in your documents, it produces this new fine-tuned LLM, which ultimately if you imagine like a custom chat interface, would interact with, and it would provide informed responses when you give it questions about your domain. The challenge here being that it's a little bit more expensive, and it's challenging to pull this, to use this pattern effectively. The second pattern that I came upon was in-context learning, or what this diagram on the right shows is retrieval augmented generation, or RAG. And basically the insight here being that the pre-trained LLMs actually give pretty good, well-informed responses if you provide them with like a blob of context along with your prompt. So the idea here on the right is that we're loading in our knowledge base, our documents, into a vector database, which allows us to do similarity search. When we get a prompt from a user with their question, we're able to go to our knowledge base, get similar context data. We get a blob of text back, and then that blob of text, along with the original prompt, can get sent to the pre-trained LLM. And it turns out we get a pretty good, well-informed response as well. And using this workflow ends up being cheaper, lower effort. You don't have to maintain a new pre-trained LLM. So let's see. So I guess the takeaway for me from this was that in-context learning works well for most LLM use cases, and it's a preferred approach especially for small data teams, without they don't have to hire specialized ML engineers. It's more of a data engineering problem. And then fine-tuning is more narrowly focused. It's better for more narrowly focused contexts, requires more know-how, and you have to host your own models and infrastructure. So it's a bit more expensive. So with that, I kind of narrowed in on the in-context learning as what I thought was relevant when it came to trying to think of like what we can contribute to in this space. So going down that rabbit hole, the next piece is, like I mentioned, vector databases as part of these RAG pipelines. Vector databases and embeddings, you'll probably hear a lot, but I think this quote up on the top right from a company called Weaviate, the vector embeddings are a way to convert words and sentences and other data into numbers that capture their meaning and relationships. So this is all just to, it's the technology behind being able to get semantically similar results when you have a prompt and try to find context that's useful for sharing as part of these RAG pipelines. And I think also, like, I'm a data engineer. I'm not like an expert in LLMs by any means. As I'm exploring this, I kind of, like a lot of technologies, got the understanding that like it doesn't matter so much that you understand what's happening under the hood on all of this. It's just that you know how it works in these pipelines and you can leverage it for what you need. Yeah, and then the other piece here was that I started to notice that there are databases that were purpose-built for vector search, and then there's also databases that were adding vector support or already had vector support, something like PG Vector for Postgres. So there's also a lot of LLM tooling that was out in the space, and some of them you've probably heard of, LangChain, LlamaIndex. They were getting lots of attention, tons of progress on their open source projects. So I dug into those. There's tons and tons of more projects now, and there were back then too, but these seemed like pretty big ones at the time. So if I sort of summarize what I noticed that they were doing is they are helping with sort of end to end of these RAG pipelines. In this case, is the app layer, so like the chat interface, prompt chaining and memory, and retrieving data and loading it to your vector database, your knowledge store we were just talking about. And it has these EL data loaders that it was building to connect to sources that you'd want your domain data from. And then similar with LlamaIndex, it's doing a lot of the same things. And it also has this Llama Hub feature that's sort of similar to what Meltano Hub is. It hosts a lot of the extractors in order to make them easier to find. So the takeaway after exploring these pieces is that they're great for these tools are great for the app layer, and we should use them for that. But the EL features aren't as robust when I started to look into the code. And it made me wonder, again, why are we not using great purpose-built tools that are already exist for these things? And we've put tons of effort into building these great communities and tools around them. So let's use them and keep LangChain and LlamaIndex doing what they're great at. So as I think about the component parts of these pipelines, I see the data layer and the app layer, like I was mentioning. We'll leave the app layer to things like LlamaIndex and LangChain because they do a great job. So let's keep them doing that. But the data layer and populating our knowledge base is something that we can help with. So again, back to that RAG diagram, just zooming in on this piece where this is something that we can help with from a data engineering perspective and from an EL product perspective, which is Meltano and Singer's main features. So what can we apply from data engineering? So as I'm thinking about this, I say, let's take a step back and think about data engineering principles. And if I was going to build pipelines that needed to do this, what things would I consider? So thinking about things like decoupling and checkpointing, subtasking, processing only new data, handling deduplication between your whole pipeline, the understanding that storage is cheap and we should keep the raw data because we want to extract once and transform multiple times. Just common things that data engineers know, and we just be applying to this new LLM world. So we have these two, when I put LLM app pipelines next to each other, next to the traditional ETL pipeline, you could see the arrows pointing. They basically just, at its core, they're basically mapping to the same pieces of work, extracting, cleansing, enriching, loading data into these vector databases. And we're going to sort of skip the data visualization or the chat interface piece for now when it comes to what we're focusing on. And that made me wonder, is it just ETL again? I think so. It looks very similar. So a learning that comes along with that we can maybe apply if we know that these pipelines are starting to look a lot like ETL or ELT. Over time, we switched from ETL to ELT, extract, load, transform, and I'll spare all the details of why that happened. But basically, the TLDR is that we want to optimize for the most expensive parts. Extracting is slow and expensive, and it only happens once. So, and transforming is fast and cheap and happens multiple times. Looks like okay, we're back. and happens frequently. So let's optimize for that. And let's skip, when we're building these new LLM pipelines, let's skip the mistakes that we made in ETL the first time around. So the takeaway there being, let's decouple expensive steps, extracting, cleaning, enriching. If we're running these LLM pipelines and we want to swap out models, we don't want to have to go all the way back to the source to extract new data, re-embed it, et cetera, et cetera. We just want to start with the piece that we need by decoupling them. More common ETL challenges from a data engineering perspective is it's easy to get data out of an API or a database and replicate it into some system, but doing that in a production grade way that you're going to feel feel comfortable running in production and know that it's robust. Here are some of the things that we're always thinking about is rate limiting APIs and outages and schema validation, handling PII, incremental state between runs, schema management, backfilling, all these things that are kind of difficult to manage. And so the takeaway is we should use an established framework that's been solving these problems for a long time. One example is Meltano SDK. There's others out there. I'm not saying Meltano SDK is the only one to use, but that's a good example. Let's use what exists out there. So I came up with this sort of potential design from a high level of like how you would build this. You can see from the left, we're sort of extracting data from our sources. We're cleaning it. We're embedding it using OpenAI's API. We're loading it into a vector database. And all along the way, we're sort of persisting this data in a decoupled way so that we can rerun pieces if we need to. And then all the way to the right is the LLM app of like the chat interface. And I'm calling that out of scope for right now when we think about it from a data engineering perspective. So implementing this with Meltano is kind of the next step. And our use case was, let's see if we can create sort of like a custom chat interface that we can ask questions of our Meltano SDK documentation website. And so I went for an implementation here that's kind of like the next step in that diagram I was showing before. We have the SDK docs on the left. We're extracting data with tap beautiful soup, which is just a Python package for scraping websites like that. We have two mappers in between. Mappers in the Meltano world are just a piece in the pipeline that operates on every single record. So we have a cleaning step and then an embedding step that uses OpenAI's API to exchange the text data for embeddings. And then we write to Pinecone, which is just a cloud-based vector database, which was popular, or I think still is popular, but so I used that. And then it was out of scope, but I found a Streamlit app for the chat interface so that we could see the improvement over time after we load this LLM RAG pipeline with our context. So if we start with what do LLMs know about the Meltano Singer SDK, I have this little demo that I'll go through as we go here. But the question being, what are Singer batch messages? And the response without our knowledge base being populated ends up being not that useful. It's sending messages in batch to a large group of people. Let's see. Sorry, my slides don't look like they're switching. Okay, there you go. So big reveal. It doesn't know much. Our context hasn't been loaded into the system. The real answer there is that batch messaging is a sort of an optimization feature that the Singer SDK has for databases that have an efficient unload operation. And hopefully we'll get a better response later as we go through this piece. But I'll zoom in sort of each part of this, and I'll start with the extract piece. You can see the Meltano YAML file on your left. All this code is written. You're basically just configuring it, giving it the inputs. On the right is sort of a sample of the page content key, along with like the text that's been extracted from our documentation. And then we've got another demo here as we kick off our Meltano pipeline that's using this, we see data starts to flow, and I will show that we're downloading these HTML files using Beautiful Soup and scraping the text out of them in order to pass along the pipeline. So the next step being, we now have the text, let's clean it. Every pipeline here is going to need to clean their data in slightly different ways. So it needs to be generic enough to let people customize. You can install your own packages, do whatever. In my case, I'm just splitting some new line characters and cleaning up some text and just passing it along in the pipeline, which leads into the next step, which is the embeddings piece, which uses another mapper for taking that text data and exchanging it with using OpenAI's API to convert the text into embeddings. Behind the scenes, also doing some things like there's limits on how big the text blobs can be. There's a token limit that this has to split those up into smaller chunks if needed before exchanging them. And then a cool thing that I thought while implementing this was that this uses a tap mapper combo in the Meltano world. So mappers are operating on individual records that are streaming, and a tap is connecting to APIs. So it actually is great because we're using the OpenAI API for getting our embeddings. So the SDK basically handled all of the rate limiting and auth and retry and stuff like that for me, and made implementation pretty easy here. So the load step to load to target Pinecone here, we show, again, just more configuration of existing target implementations. We're sending along our text data with these embeddings that we just pulled from OpenAI's API and some metadata into Pinecone. So the next piece on this demo, as it starts to finish, we see our pipeline completes. And then I'll check out what exists in Pinecone. We see that we now have 376 vectors that are loaded from the SDK website. Not a ton of vectors, but it's just for demo purposes, and we'll see what it says when we try again. So if we ask the same question as before, what are Singer batch messages? We can get a response that actually turns out to be a bit better. So Singer batch messages are, let's see. I wasn't fast enough to read the response there, but effectively, the answer is that it was correct. It gave a well-informed response. It was much longer. It gave you context about it being an optimization feature for unloading data from databases that have those features. So it's correct. And our knowledge base has been put to good use. So the next steps on this POC that I was thinking about were things like checkpointing, like I had in my original diagram, incremental upserts. We want to, as a community, have more support for targets that like these vector databases, or supporting some databases that have the vector types. And then also exploring more about the improvements in the space, because things are happening really quick. So just jumping back in to see what's changed. The takeaways here are that the Singer spec is alive and well. We kind of went through the overview there. Meltano has helped come in and embrace Singer and solve a lot of the challenges that we've seen. The blog post findings sort of demystify what's happening in the LLM space. I described it from a data engineering perspective and made the pitch that we should be using existing robust EL tools versus trying to start from scratch and build those features into these LLM tools. Those should just be used for what they're good at. And then we should be applying data engineering principles to these pipelines, because they are data engineering pipelines. So in conclusion, yeah, I just wanted to say, join the community. All of everything that I presented, that is a functional project on GitHub that does all of this. So feel free to fork it or contribute to it, whatever you want. Join our community and reach out if you're interested in Arch.